everybody, and I appreciate all of you who went through this. Let's go now and put back to my regular audio through Surface Dock. I can hear you better. And now, any one of you who has a sound, you're welcome to ask the question. Of course, as usual, I am ambitious. Jadranka, I can't hear you. Okay, you have to.
I want to thank you for the presentation. I don't have a particular question at this time. I'll let the experts ask you. I'm kind of retired from the field, but I enjoy hearing the novelties.
Okay, I didn't even, thanks for a compliment. By the way, Jadranka is, she was my classmate at Belgrade University, and she was in the so-called telecommunication weak currents, and I was in nuclear sciences department, which was supposed to take care of the nuclear reactors, and we switched the fields. She went to Canada at the time before me, a couple of years, and then finished the whole career there building the nuclear reactors in Canada. And I left that, and I never worked with that. I went into strong currents, which was not supposed to be my field, but when I came to United States, I was in control systems, and then started liking this this field, and still stay in it. All I can say is, you know, if anything, is I didn't have a chance to make a concluding remarks because time went by quickly, and we are saying this. But one thing, as I showed now today, there is many ways to make a transformer happen. And now we have what Tesla and Faraday didn't have. They only had a drive, either DC source for Faraday or alternating voltage that Faraday, that Tesla put in use. But we have now ability with the switches, capacitors, inductors to make transformer on any kind that we want. And I just show you one. My first step 5 years ago was to make this hybrid transformer. Now I have 3 prongs of direction which I want to take my research. You know, not research, but actually applying for now patents and making a prototype. One direction is really to make a high voltage DC conversion, but inherently high voltage. Why is it important now? Because at the time of Tesla, he only had Niagara Falls as a natural source of mechanical energy. And he used the big 3-phase generators at 60 hertz to convert it to AC voltage, and use a transformer with a 2-phase and 3-phase to convert it to high voltage. And then that requires also, that required operating his 3-phase motors. However, now we have one big advantage over Tesla that he didn't have at the time, and that is we have DC to DC converters, which naturally use as a source not mechanical power to convert to electrical power, uses solar power, and solar power is made really at 2-volt solar cells. Now they are putting a large number of solar cells in series to get to 200 volts or 220 volts. That's bad, because if any single solar cell is not illuminated, then the whole power is not generated. It's better to use all solar cells at 2 volts in parallel. But for that, you need a high voltage conversion. You need to convert it to 200 volts, 2 volts, lots of solar cells in parallel, you convert it to 220 volts. But then, or 400 volts DC. Then you need another DC to DC converter, which will convert it for 400 volts to 4,000 volts, and hopefully for eventually to 40,000 volts. And why that? Because if I can make now a transformer, which is fully 1,000 times smaller at 50 kilohertz than at 50 hertz, then everything, you see, the thing is, everything then becomes not only smaller, but more efficient, because if you, instead of 60 hertz generator and transformer, 60 hertz, which have a huge cross sections, and huge lengths of the wire, everything is now struck by a factor of 500 or 1,000. Okay, I'm shooting for 100, okay? And if I get 1,000, I'll accept it, all right? But that's one direction that I'm moving. The other direction, it is also the beautiful invention that one of very few that Japanese contributed back in 2014 when I had my Chuk converter family put on Orion aircraft. At that time, people at Japan invented the blue LED. And the blue LED was the only one which was missing. Green and red were already available using silicon, but he used the gallium nitride and make a beautiful blue LED, which now combined with the other, you can make a LED white light, okay? And what is the advantage of LED white light? It is very, very small and very efficient. You know, I'm using here the 30-watt LED with 100 of LEDs, and it is actually like 300-watt light bulb, you know, and it's much less electricity. The only problem is in order to drive them, because their LEDs are like silicon solar cells, you know, they need to drive them in low voltage and high current. And that's, again, one problem which can be solved now, because right now, converter, which goes from 400 volts to drive these low voltage LEDs, it becomes big, huge, even with the high frequencies. So one problem I want to solve now is to have LED drives, it's as small as LEDs, and not 10 times or 100 times bigger. That's the second area. And the third I just showed you, the microprocessor drive. It's just so insane that after 30 years, I told them what's wrong with them. You know, going to, at that time, at 33 years ago, I gave a presentation at a conference, and they were doing claiming to do 10 megahertz converter, Bell Lab and Virginia Polytechnic. I says, you're insane. You know, I'm now at 500 kilohertz doing design for Boeing, and my next design will be 50 kilohertz. And that's exactly what I did. So I think and now, I have even better mousetrap for a 1 volt, that's 40 volts. Everybody wants to use 50 volt bus to drive 1 volt drive for microprocessor. Now, I don't need a couple inductor or a Chuk converter. I can do it in single converter and have a zero ripple on the output and all the advantages that I showed you in this hybrid switching converter. And I can have isolated version which can go for 400 volt. And that beauty of that is now you can go directly from 400 volt down to 1 volt, because they need 8 or 12 processors, and each processor, you know, so really you want to have a processor right at the point where you're driving it, but then distribution current at 400 volts will be so much smaller, so you can put all this processor exactly when a microprocessor is needed. But you know what? The people in Intels and Broadcoms and all this, how you say, not Broadcom, but Qualcomm and all others, they're all in IC design, and always think that they're going to make it by using IC circuits, you know. So they don't understand the power conversion. That's my, how you say, bad luck that I'm everybody's enemy. You know, maybe my conclusion is this, you know, when I show up at the conferences, they don't want to let me speak. They shut off my microphone because I'm telling them the truth. You know, then they publish the paper. You know what is a latest? This is something which I really think is disaster. You know, not only that we have disaster, and I'll be honest with my field. The question, I will answer you myself. I'll pose the question. I was invited to patent office 2 years ago, and it was just happened to be on July 10 when Tesla was born. So I decided to give a free presentation and pay for my trip just to honor Tesla's birthday, you know, that day. So I gave that presentation and learned all about the patent office. And you know what is the situation with the patent office? It was established, Declaration of Independence, 1.7 paragraph, established that all experts in skilled in the arts and science, and they gave a copyright for 20 years, which was extended to 50 years and later to 100 now. And at that time, they established patent law. They give exclusive rights to inventor for exclusive use of his invention for 17 years. In return, that after that it becomes public property. So they say, don't keep it for yourself, tell everybody. And you know who was first patent officer in charge, let's say, commissioner of the patent office? Guess what? Anybody has a guess? Jadranka, you have a guess?
No, not really.
George Washington.
Oh, wow.
George Washington was first.
Was politicized, right?
First patent commissioner, and the first patent was issued 2 years later, like 1790. Was the first patent issued. And why I make a point about a patent system is supposed to encourage the people to contribute and then leave it to the rest of the world. And now it is opposite. Now patent office is worth nothing because it's an invitation to the lawsuit. All the big companies are going to, if you have something very important, they're going to try to publish, and it happened to me with Infineon, and I had a license to them for 5 years exclusively, and 6 years after I canceled the exclusivity, it did not do nothing. Then they filed the patent and had a patent issued. Of course, it's useless as far as I'm concerned, but that's how it works. And the opposite thing is companies which don't produce anything, they got a monopoly. Patent was supposed to be the only legal monopoly that should have been existed. But now it is not. It's just an invitation to lawsuit. And then the only monopolies are in the Facebook, on the media, and they control elections in a way. Twitter control elections. Then you have Amazon, which controls sales, and they are supposedly low cost, but they are not. You find out most of the stuff you can find out 30-40% cheaper than anybody else. The only advantage is it delivers to my door, so I don't have to go in this pandemic to order it. And Google. So you have Google, Apple in its own way. It's and the problem is the whole field of power electronics. I just tell you my honest opinion. It is flooded with information and no critical assessment. Last conference in so-called energy ECCE, electronics conversion conference expo, which used to be original conference power electronics specialist called, and they for some reason 30 years ago changed it to this name. They did the online conference in October. You know how many papers they were presented there? 1,000 papers.
Wow.
And that's 1,000 paper, just one conference in one field. And IEEE society, IEEE has 39 different societies, and 12 of them are dealing with power electronics, energy conversion, renewables, whatever you name it, transportation, and so on. And just one conference has 1,000 papers, And you know why? Because now they are, they are operating, there is no, when I started in this field, those people who are in the field were also those who are in charge of approving the papers. Now everything is approved, and this is everything gets published, and nothing gets to be criticized. So there is no inherent, criticism to stop this flood of information. And I can tell you, I was at a conference, in let's say 2007 in APEC. Well, it was the last one that was in person was 2019. It was my backyard in Santa Ana. And I got up because one guy who had nothing to say about it, he was self-appointing himself to talk about research at power electronics at universities worldwide. There are more than 100 or so people, universities, each one has 2 or 3 people. He had no credentials, and I know him from the digital equipment when I was making presentation 40 years ago and so on. Anyway, he made a presentation, and you won't believe it. I got up to criticize it, and after I just started explaining what it is, conference concocted with him, and as he was talking, he gave a sign like this, and he cut off microphone that I was talking, stand-up microphone. I had recorded everything because I expected that they're going to do that. And you know, the whole thing was he was then after that talking over me for next 10 minutes, not letting me ask the question. And 1,000 people are watching that don't mean anything. And when I was in 1988 in a conference in San Diego, when I made this statement that this nonsense going to the 10 megahertz and I do it at 50 kilohertz, and 18 people, AT&T, Bell Lab, Virginia Polytechnic, all these, 18 people signed up to shut me down that I don't know what I'm talking about. And I answered every single one. And wow. Here I found myself in front of 1,000 people. Bunch of them are my former students, professors, universities, nobody to get up and to say, hey, let's stop it. Let's have a discussions, you know. And you know why it is that way? Because the IEEE is a defunct organization. They have 500,000 people, 500,000 worldwide. There's so many societies, each one paying $200 to $300 membership. I'm a lifetime and fellow member, so I don't pay much for that. And I get this proceeding. I get proceedings of power electronics transactions, 1,200 pages every month. And how they're built on volunteers, you know, so-called volunteers. And volunteers are there. Why? Because they go to these conferences, and as a conference charges $1,500 for a 4-day conference, they also charge one day 20 different seminars, 3 hours each. And what they're used to, they're just a blueprint for people to advertise themselves. You know what I'm saying? They don't offer any education and all offer, you know, and in fact, right now, you know, IEEE charges for their webinars. I offer this as a free education to everybody in the world. Now they can join. They charge up to $100 for their webinars, you know, which is 1 hour, and which is really promotion for this consultant and so on. The field is totally disaster, you know, and something I'm hoping to do this by doing just this course, these webinars, and doing an online course, which now this situation is education is horrible. I know I paid for my daughters at Princeton electrical engineering at that time $35,000 20 years ago for room and board. Now it is $70,000 to $90,000. You know, and you know the problem is most of these universities now have 100 universities in the United States, all have 2 or 3 professors in power electronics, and the output is just you know, anything. They justify it because publishing is easy. You know, they just get everything is accepted, everything is published, and the problem is it's how you say still they charge $60,000 for 4 years, and I think now we are living in different society. Now we have all this ability to give lectures. Can you imagine now how powerful it is now that when I set up this course for 6 weeks, 2 hours every day, I intentionally made it only 2 hours per day because 8 to 10 in the morning, it is 5 to 7 in the evening in Europe. It is noontime, lunchtime in South America. It's 7 to 8 o'clock in India. I have on this conference lecture, I have one fellow, my really fan, Nathan from New Zealand. Unfortunately, from New Zealand, Australia, he has to get up at 5 in the morning to listen to my presentation. Okay, so yeah, here is Nathan. Nathan, say something. Can you say something?
Yeah, man.
Okay,
it's actually
everybody. Okay. Here's Nathan. So did you learn anything new today that you didn't learn from last online course or what?
You always learn something new every time.
Okay, yeah. All right. That's why I have you every time, okay? One day you're going to be my assistant, you know.
Well, the younger people may replace us.
That's what I'm hoping. I'm hoping now to use this, and I have too many things on my plate. And one thing I want to say is, yeah, I'd love to do these lectures to I didn't say it at the beginning, but when I gave in-person lectures, I was always, my enthusiasm of teaching was proportional to number of, not proportional, exponentially proportional to number of attendees. So now I'm extremely happy if I get 500 people on my lecture. That means my word goes out. I just need more time. As you can see today, I have so many things I can cover it. That's one thing. But I have two other objectives. You know, unfortunately, you know, I didn't mention that, but I want to make a, just recently, I was just for the sake of it, celebrating now 200 years that we took after 2,000 years that we know for magnetism, and in 2010 years, 200 years ago or a little bit more, we established a battery, and now 200 years ago we established connection, electricity, and magnetism, and you have four giants. You had Faraday, Tesla, Maxwell, and Pupin, which changed the world of we live. Only 200 years. And I looked at perspective, how much is that in perspective? I just came across, you know what, Kirk Douglas. He was very famous, of course, originally from Russia, actor. He died last year at age 103. Actually, he was months off of 104 years. And his wife, second wife, is 101 years and still living. So what I'm thinking in that perspective, you need two more than average human being, and that's your 200 years. You know what I'm saying?
Right.
How much happened in these 200 years, right? Now, of course, I'm counting with my age, which I don't want to disclose. I always look 20 years younger than I look, at least according to my daughters, and Jadranka will confirm, right? You know, so that but I'm still counting that all what is in my head, I need at least 20 years. So God gives me 20 years, and I need the time to turn this titanic ship of the power electronics, which is going into the, into this iceberg and get destroyed itself. I need to turn it around before it gets destroyed. So that's why I need to do these courses. I need to write my textbook, because there is, believe it or not, after 50 years, the only textbook I would recommend, you know, I published all the papers that originally published at the Caltech with my PhD student from 1981 to 1983, which was now 4 volumes. And actually 1976, including my PhD thesis, so it's a 4-volume book. And I encourage you to buy those, because that is the first thing you need to do to learn that, so you can follow what I'm doing now. And the next thing is I'm developing this, I call it, I hope I'll be lucky like a Tesla. You know, he in 1882, he developed this complete revolutionary alternating system, transition, distribution, generation, and finished it by 1895, now 13 years later. I hope with all the stuff that I have, maybe I can finish my stuff in 20 years, okay? And then I often like to compare that and say, and sharing with my daughter, I want to leave it to this world which does not deserve it. Because when I look at the disaster which is happening, I'm worried about my kids, you know, how they're going to live in the next 30, 50 years, okay? But I think, I hope to really make a difference. And I hope that a lot of young people will join and realize that good from a bad, you know, that's what they need to do. Yes. The other thing is nowadays about universities teaching, they are too expensive, too often too little. And I always claim it was not important what university, top university, Princeton, Stanford, Harvard, Caltech, and so on, you were, it is who you learned from, okay? And that is really the important things. If you have a right teacher, you can learn a lot. By the way, Jadranka, I remember now, you're related. I was brought up at electrical engineering at Belgrade, and my generation was blessed. We had a professor who was fantastic. he was teaching electromagnetics. Remember Surutka? He was a #1 at the time, and he was member of Academy of Serbian Yugoslav Science at that time. Very few remember. In fact, out of all the people, then after that, his student, next student was Branko Popovic, and he was also Academy of Sciences, wrote fantastic book and did the research. Then he got a student, Antonio, who also became member of Academy of Sciences, also teaching electromagnetics. So we have a strong thing. Unfortunately, when I was at Belgrade University for 4 years, I was in control system and I didn't do electromagnetics. But ever since that time, I started loving you. And Jadranka is married to a brother of Branko Popovic. So anyway, you have a big.
You should mention Zoya Popovic, the professor in Denver.
Okay, I did.
Not Denver, but Boulder, Colorado.
I'm glad you mentioned that, because it gives me opportunity for another pitch to make. I was responsible to bring Zoya Popovic to Caltech. I was in charge of I was in charge for a number of years, member of admissions committee for graduate students. And when she came to Caltech, I already became chairman of 3 committee members. There were 2 other members. I was before that for many years committee, and then became chairman. When she came, she was picked up, and she was actually that year on a PhD oral exam. Or actually, how you say, entrance exam, the best, and so on. And then the people after that, they started seeing that a lot of people coming from Belgrade University. And they didn't blame me, and they said, oh, I know why we get these people from Serbia and from Belgrade University, because you are chairman of a committee. Except after a couple of years, there was Zoya, and then after that, same year, there was, I think, a year later, there was, what is his name? I forgot. He was also... No, Maxa, but before 1 year before Maxa came the fellow who was, boyfriend of someone there, like, you know him in the name. Anyway, all 3 of them were at the exam with the 3 PhD prospective students, and we ranked them. They were all at the very top. And but now, after that, some of the professors started coming to me and says, why don't give me some more of your students from Belgrade universities? Because they showed up so well. So they changed the tune that I wasn't, because they knew I wasn't doing that. I was doing favor to university because I knew the professor who made the recommendation. So if this guy says he walks on the water, he does walk on the water, okay? They were best in a generation. So I was on a both committee. I was on a committee which was accepting new students, and we had acceptance rates of 20%. We had to offer 5 times more a position. If we had a 30 position in electrical engineering, we would offer 200, because we were competing with Harvard, MIT, Stanford, Princeton, etc. And the people will apply to all of them, and only 20% will decide to come to Caltech, eventually. So I was really in admissions committee, and then I was in a PhD committee of these people when they came to the PhD oral exam. I wanted to see how I did in picking up these people. And I must say, I did very well, okay? All this that I picked up, they came up really top. They became professor. I think Zoya Popovic is for long-term tenured professor at Boulder, right? And related somewhat to this field.
Her sister is at McGill. Yeah,
what?
Also professor at McGill. But this is becoming a little personal.
Okay, that's okay. That's what it is. I wish if anybody who was here, or these 50 people remaining, if they come forward and remember of any way that they were where we crossed the roads. Okay. Yes. Oh, here's Harvard. What can I do? I'm putting Harvard down. I'm sorry.
No. Okay, I'll hide it. Dr. Chuk, I have a question and suggestion.
Yes.
I read about all of your patents and everything, and I recently encountered a big problem my application for a U.S. patent was rejected. And the interesting part is that the rejection documents that the reviewer have submitted, it's really alluding to other patents, which has nothing to do with what I have in my patent application. And the bottom line is the reviewer of the patent says basically that I'm making it too simple. It is hard to believe that nobody else have thought of it. It's a common sense. So I remember you on the interview recently in California, you mentioned that you had a similar problem when you originally applied for your patent because, as I understand, it was rejected. It was too simple.
Okay, I think a little bit different. Yes, indirectly, you are true in a sense. When I published my Chu converter, I wrote the paper, and I now make public admissions. I am really not electrical engineer. I am a mathematician and hard, okay? And in high school, I got all my first prizes in math and physics. And why? Because I always liked logical thinking. And the patent system is made in the wrong way. The patent system is based on a thing which says, oh, I woke up in the morning and this is why I waited. I don't know why and how I came to it, but this is it, and this is I presented it. So you're supposed to, in the patent presentation, you're supposed to make it. You don't really quite understand how it works, but hey, I connected this way, it works, and you don't even have to show the prototype anymore. That's how it is. And when I wrote my paper, I had a Caltech appointed patent attorney, and I wrote this, and then just, we submitted that in the last minute because I already had a paper to be published. And if a paper is going to be published, you can't patent it. You have to only publish it after that. Okay. And he stopped me in the tracks because in my paper, I wrote the same way I wrote the paper, I wrote the patent. I went to basic principle and showed a logical step-by-step how I invented the Chu converter. You know what? My patent attorney said, you can't do that because if it shows step-by-step how you came to this and so on, then it's not patentable. It's supposed to be something you cooked up and you don't know why it works. And here I showed the logical steps from one step to another and so on. And then he said, no, we can't do that. And we had to rewrite the patent, not for me explaining it, even though I was telling it. That was the reason. Once I can explain it, then I can make a new invention based on a logic that I presented. No, they don't want that. They want to be something like a dark wader thing that you wave and so on. I have another things which since you mentioned that my favorite subject, obviously, patents, I got Dragan Maximovich, one of my PhD students, and he also, I finished in 2 years and aced him, but he finished it a little bit more than 2 years on my insistence. And I gave him a problem way back then when he came. He was my 21st PhD student out of 36. I gave him a problem which I gave to my first PhD student, Bob Erickson, and he didn't do the job right. And I told him, look, you can use my state space averaging, and all you need to do is make all possible connection of components, and then inductors, capacitors, switches, and not even transformer, just inductor, capacitor to invent things. And then use my state space averaging to see if there is a steady state. If it doesn't have a steady state, that converter doesn't exist, like a variable. And he concocted a very intelligent scheme because he had a background from Belgrade University on graph theory and all that. He concocted a system that he said, how are you going to enumerate all these different connections? And you know how many connections he could make with the two inductors, one capacitor inside converter and one capacitor outside, like my Chu converter, right? He could make 1,050,000 different connections. 1 million, okay. And then out of this 1 million, steady state, when you do state space equation on my system, only 30 or so had been valid converters, okay? And one of them was my true converter, but it was invented after the fact, in using this system. So we, at one point, and I'm telling you this because I'm a proponent of this human intelligence is much better than artificial intelligence, okay? Yeah. So at one point, I thought, and all my PhD students at the time, first, there were two different things. When I invented my true converter, coupled inductor, integral magnetics, isolated converter, all the students who were become after me PhD student at Caltech, they went to complain to Professor Middlebrook, who was together with me leading this group. He says, no, he didn't leave anything for us. I said, don't worry, there's so much left, and the thing is, at that time, my other students, when Dragan came as a 21st PhD student, we were at a conference in Florida, and my students said, okay, Dragan finally put a nail in a coffin of converter topologies. There is no more converters to be made. Okay, not so, because after that, I found out that what we are doing wrong. And we didn't, at one point I was saying, maybe we should patent this as a method. And then, but it turned out that method did result in some new converters with 1 transistor and 3 diodes. But that converter was much worse than the one with the 2 transistors and 2 diodes. Wow. Much bigger stresses and so on. So the point I'm saying, there is no substitute to human mind, and only after so many years in this field, I feel like I'm like a Mount Everest, and I'm looking down, and I see everything, and nobody sees what I see. And then I'm sort of surprised. So it's obvious to me now, but of course, when I was 25 years old, I would come up with something, and at night and dream, and in the morning I come to check, and you know what? I found surprise. It doesn't work, because in my mind, when I was sleeping, I didn't have a chance to check the signs, and one positive sign came up negative, and the whole thing came down, crashing. Now, 50 years later, I can report to you guys that everything I cooked up, it does work, because I have so much knowledge that, and I cook up some really crazy ideas, and that's what it takes now to go from a present state of the art, which is staying frozen in my mind for the last 50 years. I contributed my thing, but they didn't pick it up. So hopefully, when I come with the new ones, maybe some people will listen, and I'll be able to get someplace with it. But
yeah,
on a patent, but that is a bad thing. As I mentioned, is patent system is broken, and the government should have two things: enforce the patent system to help inventors being able to fight against this.
Piracy.
Yeah, that's right. And then also stop the monopoly of these few companies.
Right.
Which the problem is these monopolies weigh a huge capital and don't produce anything, and they are just and they are used to really spend the money freely and don't use it usefully. So that doesn't help the country, and I'm afraid that pretty soon we won't become competitive with the rest of the world, especially Chinese and Indians and Russians and the rest of it, Europe and so on.
Put Biden or Trump in charge of patent office. What a crazy idea.
Who is in charge?
Biden, President Biden, or ex-President Trump, just like in the Washington days.
Oh, forget about it.
Forget.
It's
crazy.
Dr. Chuck.
I think there is a possibility. Now that you mentioned that, when you mentioned that, I applaud actually. Elizabeth Warren was the first one who raised a question that all these Facebook, Google, and Amazon, and so on, they be broken out because they are just, and look, they're controlling elections. Twitter is controlling elections. They control. Same thing with the Facebook. And what do they contribute? Nothing. And especially Google. But anyway.
Dr. Chuck, so the interesting part on my case was that I revised the initial submission based on the reviewer criticism and asking for changes. So my attorney and I made the changes, resubmitted again, and then it was again rejected. And then it says, as a line item was like, it is too abstract. So I called the reviewer on a phone from on the US Patent Office, and I said, how is it abstract when I have a concrete results? When I implement my invention, and I do construction project management, where I combine a BIM, integrated design delivery solution, and a facility management solution, and the latest technology and methodology, which goes beyond anybody else offering in the world, I get a 20% savings on a construction project years after years. I said, how is that abstract? So the answer was,
I can give you one advice.
Abstract. I'm sorry?
Listen, I'll give you one advice, and you take it with a grain of salt if you don't believe it. I believe that the US patent system is broken. Not only for that reason, they have in our field of power conversion, which is the biggest one, 20,000 examiners.
Right.
These examiners are a reflection of the pool of what is happening in the power electronics field that I see today. You know, in the power electronics field, that's why zero in on magnetics, they don't know, they all think, managers and all the engineers, they'll think it's a transformer is a two windings on a magnetic core. You know, they don't have any understanding. So how you can expect them to get your advanced technology approved? So the only way to do it now, the American system is now part of international system, and have to oblige with the international system, which is now not 17 years from the time you submit, but it's 20 years from the time it is approved. And this is now motivated to get approval. And also, when you apply now, I apply the US patent system. A couple of years ago, they allowed you now to, same US patent office will process international applications, so-called PCT application, power PTC, power treaty company, countries, power treaty countries. And what it is you are now submitting your patent internationally. It costs 2 times more or 3. You don't have to pay translation and anything. It is done for international at the same time in US. And that way you can bypass your application in a sense, because what you'll find out, you're spending a lot of time with your attorney and so on to convince some people who are sitting there like bureaucrats, and all they feel they have a duty to reject the patents, you know. And if you go through this patent treaty countries, international, you get approval with international, I think, which are much smarter. They're Europeans, they're other countries which contribute. So once you get a PCT approved, you can get a patent approved there, and you don't really care if United States approve it or approve it late, or you can simply say, hey, PCT approved it, what the hell are you guys doing, you know?
Can you consider to send me the web link for that?
Yeah, I will. Let's
Okay,
be in
thank
touch.
you.
Well, we can get on a Zoom call, and it'll be easier handling a one-on-one rather than 200.
Yeah, okay, I will communicate with you. Thank you very much.
No problem, no problem.
Thank you,
Anybody
excellent.
else who remembers me from 4 years ago? I had a couple of people who claimed who were my students who were going to join. I didn't see anybody.
Professor Chuk?
Yes.
Hi.
Hello?
I didn't actually cross paths. Oh, my video or my audio
Okay,
sitting back.
now I have everybody. Okay, I have everybody. We are now on a gallery view. Anybody wants to talk? I'm here. I'm
Okay. You asked the people that had crossed paths with you. We didn't actually cross paths. Our paths were more tangent. When you were a grad student and then an associate professor at Caltech, I was doing my undergraduate work.
Who's talking to?
This is John Brooks.
What?
Can you?
Oh, John Brooks. Okay, go ahead. Yes.
Hi. So we didn't cross paths actually, but when you were a grad student and an associate professor at Caltech. I was doing my undergraduate work, and I heard of your Chuk converter very early on because I was the roommate with Al Cocconi.
Are you kidding?
No,
Are
I'm
you
not kidding.
That is
We were
that
roommates.
is beautiful to remember. You know what? Let me put you on the screen because we can now only view. So say it again, and I will tell you something about Alan Cocconi. I didn't know you were his roommate.
Yeah, we roomed together. He was doing his mechanical engineering work at the time, building tiny radio-controlled helicopters that were extremely acrobatic and all sorts of cool projects.
I don't know if you know.
Electrical engineering.
I don't know if you know, but let me tell you this. Alan Cocconi was my, star student. He was a master's degree program at Caltech in electrical engineering. I had him in my research group in power electronics that Professor Middlebrook and me were leading, and he was a member of that group. And then he was just before exam, there was exam in a differential equation. And Alan comes to me and says, Dr. Chuk, I didn't study anything, I'm going to fail. In any case, I didn't like this mathematics differential equation, and I want to quit. I don't want to work anymore on a master's degree. And that's the time when I started, my company in August 97, whatever, 79, 1977. I started my company, and I just said, Alan Cocconi became my first engineer. I admit it, he's the first engineer. He built for me this 4 kilowatt photovoltaic inverter for a Sandia laboratory. And then he wanted to do this solar car in a race in Australia. And he was hired by a Caltech guy who was having a project to do solar powered car. So they did a race in Australia. And he was the one
called Sunburner?
Yes. And then he was the one that went to AeroVironment where McCready was in charge. And then he was always consultant. And later on, he said, Dr. Chuk, I never worked for any other company. Only for years I was working as an employee. After that, I was my own consultant. So he then started his own company. Actually drove me in his Honda car, which was converted into the Honda Civic. It was converted electric car, and drove me in the San Gabriel Mountains. And then he is the guy who designed the first impact 300 miles range electric vehicle for General Motors. And, and General Motors leased that for, and very early at the beginning, they were only leasing 1,000 cars. And unfortunately, you can actually go on the internet and buy this Who Killed the Electric Car, because General Motors had it done and everything. In fact, General Motors offered him $2 million just to work exclusively for them. But Alan, he never worked for anybody except for me. So he wants to work in his flying cars, flying objects like drones and so on. And then he turned them down and started his own company, and eventually his patents that he had, actually, I encouraged him. He had one patent that I forced him to take it. Even I gave him some idea, and he did beautiful. Went down to full bridge converters to sense the flux, so you can ensure it that if it goes in one direction, you drive it with 2 transistors, and we go close to saturation, use this sense to drive it in the other direction. So then you are at least assured of not saturation. But anyway, so he went on with this company, built his design was put in the first Roadster. Martin Eberhard started this Tesla Motor Company first before Elon Musk, and then he licensed this technology that he built a charger, he built a DC inverter, the motor drive, everything, and he licensed it to Eberhard, to this company. Eventually, when Roadster was built based on it, and they were paying him license fees, and later when Elon Musk took over, you know what happened? Then he kicked out Eberhard, and then they changed this original design from analog circuit to digital and claim that their patents are no longer valid because they use digital circuits into analog, but it's the same concept, you know. So that's how it always happened. Money men's, they get the claim to fame, but the people, real inventors, they are forgotten down along the way, you know. So I'm glad you mentioned Alan, because I think I had a good relationship with him for quite a while. That kind of reminds me that I should actually refresh my contact. Do you still have contacts with Alan or not?
I think I have him on LinkedIn. I can send you that.
Okay, all right. Well, he's still in San Gabriel Mountains and so on. I will, and anyway, if you do get in touch with him, tell him that you're in my course, and then it's got some great stuff to offer in the field, so he could join the party, you know.
All right.
But he was really my favorite first engineer for one thing, and he was very brilliant, you know, brilliant engineer. I appreciate his abilities, you know.
Yeah, I know what you're saying about the inventors not really getting the credit that they deserve. I have over 40 patents, and I've made, you know, maybe a couple $1,000s off of all of them put together.
Wow.
Yeah. Okay, I'm glad you made. I'm just curious, how did you learn about this course? Did I send through LinkedIn, or what? How did you learn about my?
I think it was originally through LinkedIn. Yeah. We're connected on LinkedIn, and I think I ended up getting an email announcement of the one a couple weeks ago, and then this one.
I have Institute on LinkedIn. I have my Power Electronics Institute, and I have also a one-to-one connection. You're probably connected to me through LinkedIn, right?
Yeah, I believe so.
Okay. Well, send me the email. You have now my email, so let's touch base. We can talk on Zoom separately. Like I will talk to Dr. Markovich as well. So
okay, will do.
He'll help you. We try to generate a computer community of the smart people who want to do change in power electronics, right?
Yeah.
Dr. Chuk, thank you. I'm originally from Zemun, part of Belgrade now.
Hi.
Yeah, hi. I'm from Zemun. I came here on a student visa, and I get my bachelor degree from City College, and then MBA in management from Fairleigh Dickinson, and I get the doctorate from University of Phoenix and postdoctorate from Harvard. So I'm in Upper Montclair, New Jersey, right outside of New York City.
A question: do you know Slobodan Bibic? He was the same gymnasium that you were in Zemun. Slobodan Bibic.
No,
I know you very well.
I graduated in 1967, and then I went to Belgrade Mechanical Engineering University. No, I don't know him, but I graduated from Mechanical Technical High School in Zemun.
Oh, he's not electrical. He's actually has his own photography business, and he
Oh,
actually.
yeah, I know Bibic. Yeah. Oh, Dad Bibic. Yeah, Dad Bibic.
You know his father, he has the only photographic shop in Zemun.
Right, and he's the one that did my headshot for my passport.
So it's a small world, you see.
Yeah, it is a small world. And there is a lot of people from Zemun that have done very well. Like Stevan Pauschak has a doctorate from MIT in physical chemistry. He lives in Canada. He's older than me. I used to cox for him in a gala on a rowing club in the Danube. And he got his PhD from MIT, and he had tremendous number of inventions. He lives in outside of Toronto in Canada. He's from Zemun.
Listen,
I live near Toronto.
When we are exchanging these hunter stories, I should tell you something about my and Jadranka's generation. We were 1947 born, and we were first generation of electrical engineering, which had a full-blown exam. We had exam.
Entrance exam.
Right.
Mathematics exam. There were 1,300 applicants, and first 300 were accepted based on a score on the mathematics and physics exam. And then next 200 were allowed to pay for it. First time that it was paid scholarship. And I should mention Jadranka and me were among the only four students who passed the math exam with over 45 points out of.
Wow. Wow, when I took the entrance exam in mechanical engineering in Belgrade, the entrance exam was for math, physics, and chemistry, and there was 1,200 applicants. They only took 400, so it was not as hard as in yours. But you probably know my brother's. Friend, my brother graduated Zemun High School in 1960, I want to say 1963. Yeah. And on electrical engineering, his best friend was Atsa Furtula.
He passed away, but Atsa's wife is my good friend and neighbor from Zemun.
Right. So Atsa Furtula was from electrical engineering, and he did a lot of different projects in the later years throughout the world. So, but I built a project in your neighborhood, Dr. Chuk. I did a joint venture years back with the company from Laguna Niguel, Bircha Construction. I did that high-rise building in Santa Ana, the tallest building. I built that from ground up.
Wow.
Yeah, and I built all the Xerox centers throughout the whole North America. I built the Xerox center in El Segundo, outside of LX, and then also one in Toronto. I did a lot of development for Xerox in Virginia, and then also in Jamaica. So I did all those Xerox buildings throughout North America.
My husband worked in the Xerox building that looks like a spaceship in Mississauga.
Yeah, very good. I did the one
now, I should add one thing. So this means I'm for the first time learning that the Zemun is this outskirt of Belgrade, outskirt of Belgrade.
It's a town.
It's a town. It's a part of the Belgrade, but sort of. I didn't realize it had so many bright and smart people. Because Zemun is also known for its famous Zemun clan.
Oh no, we're not that. No. Thank you. No.
Very effective, huh?
That was after. That was after us.
I know. This is everything went. Listen, you're right. Everything went downhill when you left the United States, Serbia, when Jadranka left and me left. Right. After that, everything went downhill.
Right. When I was growing up and going to school, that's where they were building factories for Zmai, for the ETM and all of this, and now it's nothing. They're down to zero, nothing.
They destroy the country.
Everything.
You know what? I'm glad I left when I was 25 because I wouldn't be able to live too long and being frustrated. Something will happen health-wise, or I will be sent to prison or something. I couldn't stand it.
But now it's getting better. They have a tremendous financing coming from the Arab couple of rich people. If you look at on YouTube, all of the new development, Belgrade on the water, it's unbelievable. That's all Arab money coming. Everything is, you will not recognize it around that.
I'm afraid.
We go for a visit, yeah.
I'm afraid that it's coming with the wrong money. It's Saudi money and it's
and Chinese money, yeah.
Chinese. Well, it's the Chinese money now the most. All the infrastructure is financed by the Chinese money, and they're opening the factories and they're opening. The Chinese are now taking over, and I have a friend who is in Hungary. From Hungary, he said the same thing is happening in Hungary. So the Chinese are moving into Europe in a big time.
Listen, what China did in the last 20 years, 30 years is amazing. Yep. I just look at the statistics. I was there 40 years ago. I was in their conferences when airport was 50 miles outside of the Peking, and the Peking was little houses which were basically made out of mud. There's no skyscraper, nothing. The cars were imported from Japan as a taxi cars, but everything was bicycles. And I looked at that in last 30 years. I looked at a statistic. In the last 30 years, their gross national product went from something like 500 or 1,000 per year. It's now at 15,000, 20,000, pushing to 25,000. It's like a 2,000 per year. And when you look at all these cities, they came out of nowhere, like 100-story buildings,
But
I was in Shenzhen originally when Shenzhen was not part of China. Shenzhen was like that, but now the whole China is like Shenzhen.
Right, but I noticed when I visited a friend of mine in MIT when he was still there, they had a number of Chinese students, and it turns out from the late 70s to early 80s, a lot of those Chinese that were studying there, they end up working in the United States for about 5 to 10 years, and then went back to China, and then the government financed their companies. In addition, they put up the money to bring whoever they wanted from United States that they knew, that they met in college, to bring them there to help them develop the industry. And that's where it all started, back from the 70s and 80s.
Yeah, they're destroying Intel. Absolutely. TSMC is now making a technology at 7 nanometers, and Intel is staying at 14 nanometers. Because they're so much behind, and bloated. So, I'm afraid for this country that this monopoly that they have is easy money, easy go, and no products. And that is going to destroy the innovation. And they're destroying innovation by not supporting this. As you say, I feel sorry that you get involved with it, but I'm not surprised that is whoever you're dealing with to approve your patents, it just lost battle. Go for international patents and then forget about these Americans, and then just you get.
Thank you. I will do that. Yeah, I will absolutely do that. Thank you very much for your advice.
Yeah. Okay. I tell my daughters. There is no. My middle daughter is an attorney, and then for a while she worked as in some patent lawsuits, Sprint versus someone else. And I'll tell you, look, I don't believe in patent attorneys. I believe in myself being a best patent attorney, because nobody can describe the way I describe it, so.
Absolutely.
So you have to be best businessman, best attorney, best everything, and still it's questionable if you can survive against all these people who are, somehow abusing system, and the system is really disastrous. I don't think if they don't change something drastically very soon, America is not going to be great again, but it's going to continue in this slide downwards,
Yeah, unfortunate.
They need a big change. That's all, so that's, okay. I said, I have so far 2 people. One said, I won't say his name, if you want to check, he's a great webinar. And another guy said, thank you for the wonderful presentation. And you know what? I just share with you my standard things. After I slaved and gave a 5 days course in Europe, and Professor Milberg gave first 5 days, and I will follow with another 5 days. And when I finished 5 days to all the people, I said, look, if you like my course, tell everybody. And if you don't like, keep quiet.
Can
I say a few words?
Yes, go ahead.
Okay, first, I'm happy to sign to those courses. I heard name Chuk Converter many, many years ago. I was surprised how it worked. It was Enigma for first, then I built it, then I found, oh, it's a reality. It's a step. Today, I got information that Slobodan Chuk replaced a helper in experiments Faraday many, many years ago with the transistor, and used capacitor to filter out AC component. which is excellent. You told us very interesting about patent and IEEE. It's exactly like happened with religion. Original definition, religion is a group of people, church is a group of people that follow the same philosophy. It may be technical philosophy. But later, what happened, it became an institution to get money.
Yeah.
This is one more proof. Yeah. And I will recommend your lecture to my friend. Maybe somebody is interested. I'm originally from Kiev Polytech. Got PhD.
Where?
Kiev, Ukraine.
Ukraine. I detect a slight Slavic accent, or I would say not Slavic, but heavy Russian accent, right? Because we have the same thing.
Careful,
right?
Careful.
Yeah. It looks like fresh blood from Europe is feeding and keeping United States brains running.
Yeah, that's right. But you know what? When I was at the Jadranka will confirm, with electrical engineering, we studied mathematics. All our, collection of problems in mathematics were in Russian, because they were 10 times cheaper than anything we had, and we were buying those and learning from textbooks and Russians' collection of the problems, and that was,
We have plenty of intelligent people, very, very intelligent people in the United States. But the problem is, like Professor Chuk was saying, the decisions are made not by the intelligent people,
exactly,
by the money men, by the politicians.
Exactly. We had the joke that American university is a place where Russian professors are teaching Chinese students with mathematics. It may reflect something. Yeah. Okay, and I hope next lectures will cover a lot. It's useful for me. I see I spent a lot of time designing high frequency inverters and transformer saturation, and the way how to use was very important.
One announcement which is not clear. I wanted to really make an effort that all the people, there were 200 people who claimed they're going to join. I think we got 60 or 70, that's okay. But a couple of people asked me they couldn't come to the meeting. Can they get a recording of this? I did record the whole thing. But I told everybody, yes, if you attend my meeting, one award is you'll get these 2.5 hours by now, or 2.5 hours.
More.
Oh, it's more. It's like 8 to 11. It's 3.5 hours.
Yeah. So you can charge us.
You'll get the recording of this 3.5 hours. Why? Because I want you to be my messengers and to share with your other people and say, this is the place to go and learn. And don't go to this university that will charge you $70,000 a year for 4 years.
Right.
And you won't learn. Come to my course, and in 6 weeks or 1 month and a half, you're going to learn. I give you a certificate, and you say, I got a certificate, Professor Chuk. And if that is not good to get your job, send me the guy that you took, interview, and I will then berate him and say, how come you didn't take my guy? He knows everything.
That's great.
But there is opposite side, the Inquisition, scientific Inquisition. Oh, Professor Chuk recommended you probably have either too many brains.
Yeah, that's right.
Or you may be dangerous.
Disqualified by being too smart. Because you're going to take his job.
Overqualified.
Yeah, not only that. You're going to take his job. If he's a manager and he doesn't know anything about technology, and you start showing that you know all about it, then automatically he's afraid of you. You're taking
exactly.
Yeah.
Exactly. Competition.
Yeah.
For money.
When I was a manager, I loved to hire people that were better than me, at least better in something.
But this is real manager. Most managers are thinking only in terms of money and career.
And protection of their own job.
Yep.
Exactly.
Yep.
I enjoy when my schematic is working and show result.
Great.
This is when I'm happy. Some other people enjoy, okay, I have to grow next few steps that I will be CEO.
Okay, now I'll share one of my experiences and related to the patent office. The patent office used to have, in the first 50 years or so, they were demanding that you have a proof. You have to submit a prototype. And after the first 20 years, they had to build 3 buildings to keep all these prototypes as a proof of the patent. So they avoided that, and there is no condition now you have to prove with the prototype, with the, you just simply want. However, I had my own habit for 50 years. Each time I submitted a prototype, first when I was Caltech, I did it myself and with some students. Then when I was in my company, I had my engineers who built the prototype. I would use the prototype, test it, and submit a testing result. However, these times are gone. Now I have a much better way. I didn't have a chance to share it today, even though I have prepared it. I showed you this simulation only as a result of it. I got into the learning about this different simulation program, zeroing on one. I dramatically improved that Plex program, which is now much better than they would have to offer, because I have my knowledge of state space averaging, and I can avoid all these initial conditions which are arbitrary, and then you spend a lot of computation time getting the wrong results, and have a problem of the not coming to the solution or coming to the wrong solution. Anyway, I now use that program with my enhancements to speed it up and make it accurate and not get bogged down in non-existing solution. And now I submit patents where I just submit a result of my simulation. Because my simulation, I believe more, not only that, it does 2 things for me. When I have some new ideas, if I test it with the simulation program and my enhancement of it, very often I happen to improve it. If I get into some situation where it doesn't work as I expected, that is my tool. I'm using that program like a hammer, like a tool to come to the solution. And then eventually use it as something that I submit, which is independent of a particular device, independent this transistor, that diode, that magnetics, and so on. Just to me, that is the best proof there is. That means suddenly anybody can do that and repeat what I did, and you don't need to store it with a patent office. They wouldn't allow you, but that is to me the best proof, that, and it helped me as a tool, and it helped me as also to write the patents and make it clean. And just one thing that people said about patents, I enjoy writing the patents because there is nothing like when you have to put it down on a paper. Right. Then you have to review it and find out, is this everything said, or if it's not, come back to it and add more to it and improve and so on. So to me, many people complimented me that they said they looked at some of my patents and each time reading it 3rd or 4th time, they find a few more things that they missed first time. And it is actually, at one point, I'm even thinking to put all my patents that I have submitted as a collection, like a 300, 400 pages printed book, because that's something that you don't have to collect, and you can have it, and you have fingerprints to learn. It's a learning tool, and of course, what I wrote 10 years ago and what I'm writing now, it's a different level, but nevertheless, it is a teaching tool. And I'd love to write. I'd love to write a textbook because I think I came to the point that I now finally, as I said before, not because of trying to brag about myself and so on, but there is one thing about human mind. When you focus in on one field and constantly you learn more and more. You are more looking at it, you see more things you didn't see before. And sometimes I look myself and I said, how come I didn't see that 20 years ago? But it takes the time, it takes the knowledge to get to that level that you can really fully understand, okay?
Very good, thank you very much.
Yeah.
Thank you very much. It was very informative and very good, thank you.
Yeah. Bye-bye.
All right. I'll be in touch with you, Dr. Chuk.
Very good. Feel free to contact me. You have all my connections now with the email addresses and several of them, and Zoom. We can get on a Zoom, and let's keep in touch and let's get join the revolution. I think we are really in a big thing. I think big things will happen in next 20 years, and I don't think we have to wait till next century, 20 years, but we can do it in this 20 years. While I'm around. Okay.
Thank you very much. Cheers.
Bye-bye.
Sir, could I ask you one question before you end?
Okay. What? Who's calling?
I'm Srđan Lale from Sarajevo, Bosnia and Herzegovina. I have one question regarding your presentation. From your perspective, how do you see the research field of control methods, control structures in power electronics converters? Is there space for some real improvements, or are there some things which are doing wrong in that field, not only in the field of topologies or switching?
Okay, thanks for that question, because I have very, very specific answer. When I started, and I mentioned today, when I started my field, I started in a control system. Last 2 years in electrical engineering in Belgrade, I was supposed to be a system professor in control systems. And I had a good background in a control system because I was going to do nuclear engineering and control nuclear reactors and all that stuff. When I came to the United States, I did my master's in control system, state space, and so on, classical Kalman and Bellman and all this state space theory. And that helped me when I came to Caltech to come up with a method of linear system of state space. I actually adopted it and to make general method of state space averaging, which was half of my PhD thesis. And I did also invent this, the converter along the way, which essentially motivated me to come up with the state space averaging because we had all state capacitors, inductors. However, and I used that and developed a program which is, we call it the SCAMP, which you can use to basically design your feedback control systems and all that. However, my latest research, and unfortunately what happened with this whole field, engineers don't like something which is a little bit more sophisticated to learn, so they just dropped learning my state space averaging, and there are a bunch of people, including one of my own PhD students, who are peddling, I must say that, who are peddling the shortcuts. There are no shortcuts. There's only one method which I covered in my PhD thesis 45 years ago, which is April 1st, 1976, when I published my PhD thesis, which is really correct method. All the rest of the shortcuts is exactly what? Shortcuts which don't solve any problem, and the engineers love it now because they think they got the results. They got the wrong results, that's the problem. But now the question comes to the feedback. And I have my own very much, feeling that I developed recently about the feedback control systems. It was great in the good old days when we were at 80% efficiency, when you had to operate over a wide range of different conditions, like different voltages, different load condition, then converter goes into different mode of operation. One is, discontinuous conduction mode, conversion changes, then you have to have a feedback. However, I will point out to you one thing, which I came out with the conclusion. It is my state space averaging is great to give you now steady state conditions, which you can use to analytically to calculate, use as the initial condition for simulation program. That's a great tool to speed up simulation program. Do I need a feedback control? Well, one thing what feedback control does is limit your bandwidth. You understand? So if you are trying to get the converter, like I showed you today, with the demonstration, which will change current from 100 amps to 10 amps and back to 100 amps very quickly, your feedback is a limiting factor, because if you close the feedback loop, the best you can hope is a bandwidth of 10% of the switching frequency. So if you're switching at 100 kilohertz, your bandwidth is 10 kilohertz. However, if you operate open loop, then your bandwidth is 100%. You don't have a limitation on it. I'll give you, and you don't have a problem of stability, because once you have a feedback, you have a problem of stability and a problem of transient response and all that. All of that goes out of the water on the condition that if you can make your converter, and that's what I did with my Chukbak 2 converter I demonstrated today. You can go and have a converter which is 99% efficient. You don't need a feedback control, especially because if you're a converter, like I showed you for this converter, it never goes into discontinuous conduction mode, operates at continuous conduction from no load to full load. Not only that, you don't need a constraint on the feedback.
Are we hearing anyone?
Hello? Yes?
Oh, yeah. I don't know. I lost the connection for a while, but maybe I can help to look from the different perspective and respond to our colleague Srdjan.
Yes.
It's I was working in the nuclear industry, and we did automatic control of about everything. So automation and feedback loop and control was very important to do everything in controlling the reactors, automatic change of fuel, you name it. It was all done, including simulation, announcement, and providing information to the operator. So I think it's a great future in what you were asking about whether there is a future in control. Of course it is. It's all becoming a field in control.
Okay, I'll tell you now. You can hear my finishing part. I think what is happening now in my system, it's of course nuclear reactors is a much more complicated beast, and you have to make sure that you don't have like what happened that they're controlling it. Like at one point they had a contamination and the reactor went out of the things because they're dependent on plotter, and plotter didn't show that there's critical mass and all that kind of stuff. But in my field it's similar. What you know what happened with the I use that as an example. This American program with this previous, they remind me of the second, that they take off as an aircraft and land as an aircraft, right? So they take off.
Shuttle program?
Space shuttle. The space shuttle went, and a space shuttle never had a feedback used in the control system, never. And why? Because the feedback has one problem, and that is when you have, you can, under certain conditions, you can get instability problem, and you cannot, and when it's unstable, you don't want to be there because an aircraft crashes. And they operate with modern computers. They operated as an open loop system. They had a very powerful, not original space program at Apollo, but with the space shuttle, they had computers, they had wind tunnels, and in the wind tunnels, they were simulating all external conditions, which means wind this way, wind that way, and the other condition, this and so on. And when they're landing, you know how they're landing? They're landing, controlling, they're breaking down by changing the pitch of the aircraft. And then they had all these tiles below to take all that temperature, and thereby increasing the pitch, they were braking effectively, and eventually at the end they're landing. They're controlling that pitch and all that, and it was all control open loop. You know, open loop, because they wouldn't get in. First of all, you had a fast response, and as fast as you can, because you don't have a closed loop limitation of the feedback. And the second, you have, no stability problems and get out of hand. Now, what I found out, if you look at this article they published, and I'll post it up for those who come to the course, of course, you'll find out when I get to 99% efficiency, and when I don't have a change of operation or mode of operation, I operate the system open loop. And that means that, and that is where I'm going now. I can make a number of converters, new converters where I have a high efficiency, over 99%. You don't need, you really needed the feedback because there is sudden change of mode of operation from light load to full load, completely different conversion function, and you need to get a system as fast, and you need to get it out of the stability problems. So yes, at one point I was there who generated the original state space averaging method and program that can use to design feedback, but now more or less I see it. Reality is that you're better off without feedback. You know, if you can do it. But for that, you need high efficiency, you need no change of operation. And to get a high efficiency, there is another thing which I must say, it's interesting. If you want to close, you know, from my long time experience in this field in the control system, so I can share that with you. You know what's the problem with the classical feedback control? You have these bad inductors and capacitors, and they create the second order filter. Second order filter is having high Q. And if the filter is 100% efficient, no resistances, the Q is 50 or 100. And if you do make a simulation of it, you will have that this, if you want to make a system to regulate, and you want to make it very efficient, when you have a closed loop, you're facing the problem that you have your loop gain transfer function has these spikes at the moment. The more efficient you are, the higher Q, and the higher the problem is for you to close the feedback loop because they are along the way. You see what I'm saying? So if you're open loop, you don't care what the Q is. You know, and you can do a still regulation. And what I do feel. Still what we need is a regulation against a sudden change. So I keep this way open loop as far as load change, but what about input voltage? Input voltage changes suddenly, or 50 volts to 100 volts, or the other way around, or whatever. You know what? There is a simple classical system that you control the slope of the ramp. So, and you make a slope of the ramp, which is use comparison and duty ratio, you control it with the input voltage. So input voltage changes 100%, doesn't matter. In single cycle, you get a regulation against input voltage, but this is feed forward, it's not feedback. So you have a feed forward and you have this and you're done. You know, but the only problem is you have to make converter very efficient and very small and so on. And as I explained, you know, we are getting now with this new kind of magnetics, as I said, if you go and make magnetics smaller, that means my inductances will be shorter, and my inductance will have less copper losses. So therefore, there's no damping. So the whole system, when it's becoming 100%, say theoretically 99.9% efficient, there's no damping. And if you have no bending, you have a horrendous problem to control it. So why bother?
Bodan, I will have to interrupt you again. I think there is room for everything. Feedback and redundancy, and this is what nuclear industry and avio industry depends a lot on. And this is redundancy of the different loops, and then you pull the loops and check before and after what is it, so that that computers can make a decision about the controlling or control or whichever way. There is a room for everything. You simulate.
No, I'm not saying that.
Redundancy, you do also not only redundancy, you use parts of a different manufacturer. That's exactly what is being done in nuclear industry and the avio industry, which are probably the most advanced in a control.
Well,
control.
I agree with all of what you said, because you are dealing with a much complicated beast. Here we're dealing with a simple beast, which is a converter, okay? And then what I'm saying is, if I can control it now and under conditions that our objective is to get as high as close to 100% efficiency, where you will have all the problems with this dynamics and cues of the filter and so on. And in fact, you know, what I'm avoiding that now because I'm not using those inductors. I'm using in different ways, you know, so eliminating those inductors. But and in fact, the whole point I'm doing now is eliminating inductors as per se and using everything with an AC, treating this to DC converter as a system which has an AC transformer in it, and hopefully eliminate everything else which limits the power, spinning power and all that, okay? All right, so anyway, it was interesting. I think I know we could stay another 4 hours as far as I'm concerned, but I'm sure you have a husband and wives to go back to. They get back mad at me, and I don't want them to be mad at me. I want you to come to the next course.
Okay, it's all on the distance learning, so don't worry about it.
Okay. Well, you know, if I have to worry about each of your personal situation, I've been in trouble. But so I'll try not to worry about any single one. That's your internal situation. Right?
Okay. Well, thank you very much once again.
Okay. Thanks a million. And
Thank you very much.
Valerie, so let's see if everybody's there and everybody is happy. Andreas, Kostin. Yeah, I see some of you, but most of you are hiding your faces.
He's my better half.
That's right. Okay. What about Zoran? Was Zoran here?
Yeah, he was.
Of course, I was there all the time.
But he's getting ready.
Okay. Zoki.
Oh, there, we're getting ready for the...
Listen, hold on. Show up at least for a second. Okay. All right. Now, you can show up now. And I mentioned you and your brother and
Yeah, I've heard. I was there all the time.
And I was hoping you're going to show up and say, yeah, that was my brother, but you know it's.
Well, we don't want to show this whole thing as a family.
No, I know the women have a problem, but as I told everybody, if you come to my Zoom talk, it's a surprise to some of them. I look at 20 years younger. You know why? Not only that I shaved, but also I put this, this Zoom has ability to put it on facelift. So you get a free facelift. So I look 20 years younger. Only
why did you tell me that? Okay, that's why I'm called.
So don't worry. You just have to use Zoom properly, so women don't have to worry about a makeup and all that. You look better than ever, you know, on a Zoom. So there's no problem. And some people, like Andrews, is young and has a big bushy hair, so he doesn't have to be. Doesn't have to be. You don't need a facelift, okay? But
okay.
Once you get, listen.
Once again, bye.
Once you get to my age, you are going to get your eyes. You're going to replace the cataract surgery. Will replace your eyes, and you won't need any more glasses. I have my glasses for 40 years, 50 years, because of astigmatism. And now when I get cataract surgery, I drive and watch TV and do everything with no glasses. It's wonderful. You know, the medicine is wonderful. And I told my daughters, some of them inherited my things and they're still having glasses. I said, just get that surgery and get rid of glasses.
Okay, bye-bye.
Bye-bye. Okay.
Bye.
Say, everybody, take care.
Bye. Thank you very much.
Thank you very much.
Dr. Chuk, can you stay just for a second?
Yes.
Dragana here.
Yes.
Your next course, is it starting, you know?
My next course, I'll send you, it's a delay, delayed, rescheduled to May 3rd. Because I had this management problem, which happened at the last minute. So I had to delay this for 2 weeks, my webinar. And then I delayed the course for beginning of May, which will fit in my schedule. So I can still do it by middle of June. So it'll be 6 weeks starting May 3rd, which is Monday. Okay? You get it? Did you get it?
Thanks a lot. Yes, thanks a lot. And hopefully sometime we can talk about Super Micro and your email, which you sent to me.
Okay.
Okay.
All right. I will now publicly ask you a question. Did you learn that actually Google had this presentation at Virginia Polytechnic conference? Is that correct?
Yeah, I did not know about that. Okay, so.
Okay, let's talk separately on it. Yeah.
Yes, thank you.
I want to learn how did they manage to go from 12 buck converters with a simply inductor to 12 transformers. That is going from one disaster to another. Okay.
Yeah, we can talk about that.
Yeah.
Okay. Bye-bye, everyone.
Okay, and I didn't have a chance to. Remember when I finished my online course. Go now on YouTube and find the tune, which is called "We Are the World." It's a 3.5 minutes, the famous song played by the 40 singers at the time, and I pronounce this to be anthem for a power electronics. Celebrating a power electronics revolution. Okay, so. Instead of playing it for everybody, just go to it, and I may actually upload it on it. There was interesting tune, how it was built. It was, I was going to share it with you, but I will share it now. I'll make you a link when I send to everybody. Everybody is going to get a link to this presentation, and also link to all these PowerPoint things that I used. And at the same time, I will send you the link. It was 1 hour, which was made by Jane Fonda as a narrator, but how they made it. It was made in 1 day and 1 night by all these 40 singers coming from all over the world. And you know what it was, how it was organized? The organizer, have you ever heard for a singer named Harry Belafonte? Harry Belafonte organized all these singers, invited them to come and make this song with the Michael Jackson and Richie or whatever his singer. And in the middle of that trial, they spent a whole night and the morning. In the middle of that trial, my famous singer, what was this? Not Harry Belafonte, but was also great. He started the song of Harry Belafonte, and everybody followed up, and it was one of these famous songs of Harry Belafonte. Harry Belafonte is, by the way, still alive, like 90 years plus. And the other singer died, but he was, remind me, the very, not Fats Domino, but what was this other one? At the moment. So he started singing and everybody accepted it, and it was fantastic because all these famous singers, they did a tribute to Harry Belafonte because he organized this whole thing. He put the money behind it or whatever. And it was just wonderful feeling that the world united in this Africa, we are the world, and I think we need something in this field that the people rebel and stop this downward spiral of power electronics, which I think it's I feel the next 20 years in power electronics will be critical. Either they're going to go and do the same thing for the last 20 years, or we are going to make a major breakthrough. And I hope to be part of it, and I hope you will join to it as well. So really, thanks for coming to the course. And as I said, if you like the course, spread the word. If you didn't like it, keep quiet. Okay? So, all right. Thanks a million, guys. And,
Goodbye.
very good. Okay.